Welcome to Astronomy Daily, the podcast that brings the cosmos down to Earth. I'm Avery. Give us 10 minutes and we'll give you the universe.
And I'm Anna. And in the show today, Avery, we've got everything from missions to Mars, facing off with solar storms, to a historic first glimpse of space weather on a distant star.
It's going to be a journey. We'll also be updating you on our interstellar visitor and uncovering the hidden family history of one of the most famous star clusters in our night sky. So let's get right into it. First up, Blue Origin's big day at the launch pad has been eventful.
That's one way to put it. They're trying to get their New Glenn rocket off the ground, carrying a pretty important payload for NASA.
Exactly. This isn't just any launch. It's carrying the two Escapade mission satellites, which are headed to Mars to study its magnetosphere. This is a huge deal for Blue Origin. It's their first major science mission for a paying customer, and that customer is NASA.
No small amount of pressure then.
None at all. But the universe had other plans. First, they were delayed by cloudy skies, which is pretty standard. But then they got hit by the fallout from that recent, really severe geomagnetic storm.
Right. And that storm was a story in itself. It was responsible for those incredible auroras that were seen as far south as Texas and Florida, a beautiful but powerful reminder of the sun's influence.
It really was, and there's a certain irony in a mission designed to study space weather on Mars being delayed by space weather here on Earth.
There absolutely is. Once they get there, though, the Escapade satellites have a fascinating job. They're going to orbit Mars and study how solar particles, the solar wind, interact with what's left of Mars's magnetic field. The goal is to better understand how Mars lost most of its atmosphere over billions of years.
A planetary autopsy of sorts. So we're wishing them clear skies and calm space weather for their next attempt. But speaking of that geomagnetic storm, it was caused by some seriously intense activity from our star.
That's our next big story. Just recently, the sun unleashed the most powerful solar flare we've seen in 2025. It was categorized as an X5.1 class flare.
Wow. For our listeners, X-class flares are the biggest category, and X5.1 is a monster. That's the most intense flare since back in October 2024.
It is, and it had immediate effects here on Earth. The blast of radiation caused significant radio blackouts across Africa and Europe on the sun-facing side of the planet.
So that affects things like high-frequency radio communications used by airlines and mariners, right?
Precisely. The bigger concern now is whether a coronal mass ejection, or CME, was associated with the flare and is heading our way. NOAA is keeping a close watch. If a significant CME does impact Earth, they might issue a G4 geomagnetic storm watch.
And the G4 is serious business. We're not just talking about pretty auroras then. That can cause widespread problems with electrical grids and communication satellites.
Exactly. It's a powerful reminder that we live in the atmosphere of a very active star. But what's really amazing is that we're now able to see this kind of weather happening on other stars too.
That's right. So while on the subject of CMEs, it's not just here in our backyard. This next story is a groundbreaking one. For the very first time, astronomers have directly observed a coronal mass ejection from a star that isn't our sun.
It's just incredible. We've theorized it happens, but to actually see it is a huge leap. So what did they see?
They were looking at a red dwarf star, which is about 40 light years away. They used two different observatories, the XMM Newton Space Observatory to watch for the initial flare in X-rays, and then the LOFAR radio telescope to detect the blob of ejected material.
So they caught the flash and then the cannonball, so to speak.
That's a great way to describe it. And this isn't just a cool astronomical first. It has major implications for the search for extraterrestrial life.
Because red dwarfs are the most common type of star, and we found many exoplanets orbiting them in the habitable zone.
Exactly. But red dwarfs are also known for being extremely volatile, especially when they're young. If they're constantly blasting their orbiting planets with these powerful CMEs, It could strip away their atmospheres and make them completely uninhabitable, even if they're at the right temperature for liquid water.
So finding life might be less about the address and more about how stormy the neighborhood is. It really refines our search.
It certainly does. And it's not just energy reaching us from other star systems. Sometimes we get physical visitors.
Let's talk about our latest interstellar guest, Comet 3I/Atlas. A new image has come in and it's looking more spectacular than ever.
This is only the third confirmed interstellar object we've ever detected, right? After the mysterious Oumuamua and the more comet-like Borisov?
That's right. And this new image shows that its ion tail has grown significantly longer and has much more defined structure. It's really starting to put on a show.
And that growing tail means it's becoming more active.
Exactly. As it gets closer to our sun, it's heating up. This causes volatile materials on its surface, things like frozen carbon dioxide, to sublimate, turning directly from a solid ice into a gas. That gas and dust is what creates the tail we see.
Which gives us a chance to study its composition.
By analyzing the light from that tail, we can figure out what it's made of. This is an incredibly rare opportunity. It's like getting a sample delivered directly from a distant, unknown planetary system, telling us about the conditions where it formed millions or billions of years ago. A true cosmic time capsule.
From a single visitor from afar to a massive family reunion right in our own backyard. Our last story today completely reframes one of the most recognizable patterns in the night sky.
You're talking about the Pleiades, the Seven Sisters.
I am. But it turns out that famous tightly packed little cluster is just the bright, shiny core of something immensely bigger. Researchers have discovered what they're calling the Greater Pleiades Complex.
That sounds impressive. How much greater are we talking?
It's staggering. This stellar network stretches 2,000 light years across. It contains thousands of stars that were all born from the same stellar nursery about 120 million years ago, along with the main Pleiades cluster.
So how did they find them? These sibling stars are scattered all across the sky now.
It was some brilliant detective work. They combined massive data sets from three sources: NASA's TESS, ESA's Gaia, and the Sloan Digital Sky Survey. Gaia tracked stellar motion with incredible precision, so they could find stars moving in the same general direction.
Okay, so they're traveling together.
Right. Then they used test data to measure the star's rotation periods. The speed a star spins is a really good indicator of its age. Younger stars spin faster. This allowed them to find stars that were the same age as the Pleiades. And finally, they confirmed it by checking their chemical composition. Siblings have the same stellar DNA, so to speak.
That is fascinating. So when we look up at the sky, we're not just seeing random points of light. We're looking at these vast, dispersed families drifting through the galaxy.
That's the takeaway. It completely changes our map of the night sky. And this new method could be used to trace the origins of other star families. Perhaps one day we could find the long-lost siblings of our own sun.
What a thought to end on. From solar flares affecting us right here to finding the sun's family tree. That's all the time we have for today's Astronomy Daily.
We covered a lot of ground and a lot of space. We hope you enjoyed the journey. Join us next time as we continue to explore the latest news from across the universe. I'm Avery.
And I'm Anna. Thanks for listening. Clear skies, and of course, keep looking up.